Okay, so in this video, I'm gonna show my DIY installation of this 5-ton whole house AC system behind me here. And you're gonna wanna stick to the end because I'm gonna share the savings I saved by doing this installation myself. Now, the point of this video is for me to show my detailed installation and to let you, the viewer, decide if you think it is a DIY doable project yourself. The general concept is pretty straightforward. You buy the components, you place the components in position, you hook up the threaded line set, and you run power. And so my installation is going to show the install from a AC replacement situation where I can reuse the power in the existing ducts. So the first thing I did with this installation is I wanted to get a power reading from the old 5-ton system. So I took my power meter and I got a reading, and the reading off of the old system, just the condenser itself, was reading about 24, 25 amps. And then from that point, we had to take the old system out. Now, big consideration on the DIY aspect of putting in a new AC system is you got to get rid of the old AC system if you're replacing an air conditioning system. And that's a technical and somewhat involved project in itself. And I think the first step you need to do is evacuate the refrigerant from the old system, and that likely is going to take a specialist that knows how to do that and has the right equipment.
That's a recovery pump.
Right.
That's a vacuum pump. So that's an empty cylinder.
Right.
So I evacuated it to get any moisture, non-condensables out of it.
Right.
Another option potentially may be to pump the refrigerant back into the condenser. However, I get concerned with that method because there's some safety considerations with that. Also, if you leave it for a scrapper, there might be a chance that that scrapper is just going to release that refrigerant into the environment, and that would not be good for the environment. So I think the proper way to do it is to evacuate the system, and then you got to get rid of the components, the air condenser and the air handler, and this stuff is heavy. So in this case, I have to take the air handler out piece by piece, and it's going to be a bear. So something to think about when considering that DIY aspectness of putting in a new AC system. All right, so next step, I need to pour a concrete pad so the air condenser can sit on it. And all I did here is I filled up some extra space with some compacted aggregate, and I'm going to pour the concrete on top of this and level it smooth. All right, package just arrived. So that's going to be fun. They're super heavy and super big. I don't know how I'm going to get them to the back.
Okay. Alright, ready when you guys are. Okay, go ahead. Yep. 1, 2, 3. I think I want to keep it right. I'm gonna. Okay, so now for me, we're at the most difficult part of the project, and that is tying the air handler into the existing ductwork and intake. And this is a little overwhelming for me because it's not my specialty. This is kind of a complicated room here. I don't have a clue what I'm going to do yet. I am going to go ahead and rip out the intake, which was plywood, and it has gotten wet and moldy over the years. So this is where the project becomes a little iffy on whether it's a DIY type deal or not. So I'll check back in when I get it done. I don't have a clue what I'm doing yet. Okay, so here's what I came up with for my air intake box, and I have 2 air intake grills on each side, and those will have air filters in them as well. So that's giving us 2 big openings to suck air through, and then there's 2 giant 24 by 24 inch vents coming through the walls here. So I've got my base and intake box in place, got the old duct board cut back, kind of a clean square cut. Now what I'm going to do is actually go ahead and put the air handler on top of this box. However, it's super heavy. I don't have anyone to help me. So I think what I was going to do is take some of it apart. I'll probably take out the coil. It's a coil. We want to take that out. Maybe a big old fan too. See if that lightens it enough so I can lift this thing up myself. Okay, I just opened this up. I'm looking at the coil right now. There's some sort of wire, probably a sensor of some sort that's going up into the control box, and it's attached directly to the coil. So I don't think I'm gonna be able to take the coil out as easily as I thought. So I think I'm gonna have to come up with a strategy to lift this heavy thing. So yeah.
So that went in pretty easy with 2 people. Now I gotta finish off my ductwork. I'm doing the best I can with what I have, but basically I'm gonna tie this in, or I got some new pieces here, into the old ductwork, and then we'll be able to move on. So to build the duct boxes, I am going to use this foam board, and this is actually foam board I recycled from the old AC. But anyway, you gotta cut this stuff to shape. I'm just using a razor blade, scoring it down. And then basically after I cut my ductboard to the size I need, I just kind of build this box out. So I just kind of put it in place, kind of like a puzzle. And then this extra would fold over. And then I'm just using this metal tape here to attach the ductwork. So for my intakes, I'm just going to use these 20 by 20 grills, and these actually have a space for the air filters to go in. And I'm going to use 2, 1 on each side. So this 5-ton air handler will have 2 20 by 20 by 1 filters for it. 5-ton air handler is going to move a lot of air, so I think having 2 air filters, 2 big intakes will be ideal for adequate airflow. And these are pretty cool because I can just pop this open and then insert my filter here, close it up, and we're good to go. For the next step, I'm going to run the power to the air handler, and this is one part of the project where I'm a little bit lucky, is that I can reuse the existing wires that ran the old air handler. And basically all I have to do is pop out these knockouts here and then run this through and connect it that way. Then I put the lock nut on and then just tighten it down. So there we go, we got our main power wires coming in, and then I'm going to hook up a breaker here, and I'll show you that in a little bit, special breaker, and that will tie into here and ground to here, and that will take care of the power to our blower, our air handler, and we're not running auxiliary heat in this unit. Right, now I got everything in place in here. Now I'm gonna go ahead and connect the line set, and this is where this is supposed to make this project easier. Again, we're just gonna thread them in place. We don't need the vacuum or pressure check because these lines have refrigerant in them already, and the air handler coil has refrigerant in it as well, and of course the condenser as well. So basically what we're gonna do here is take these little connector things, we're gonna thread them in, tighten them down, and then we are going to attach the line sets and tighten those down as well with big wrenches. It's recommended to tighten these to a certain specific torque using a torque wrench. However, I've done that in the past and I didn't feel like it worked real well, so I'm just gonna use crescent wrenches and do it by feel. All right, so first thing, I need to remove this cap. And then also this cap as well. Now, a little fun fact to note, this doesn't go into there. We need the coupling for that. Okay, here is our connecting thing. First, I'm going to put this on and hand thread it. Tighten it down. Take my 2 wrenches. Okay, it's pretty snug. And then I'm gonna line this up to thread in nicely. And then I'm just gonna tighten this down. Not a lot of torque on it, so I don't need the other wrench yet. Just takes a while to do this. Okay, once I get snug, I'll use another wrench. Now that I'm getting snugger, using my other wrench. See, basically I'm using this wrench to take any torque off of the coil itself. And this is what's supposed to make this process a little bit more DIY friendly. So now I gotta start snugging it up here a little bit. Okay, that's pretty snug. That's that one. Now we gotta do this one. We're gonna repeat this process up here. Again, hand thread this on first until it gets snug. Just make sure the threads are nice and lined up.
Now it's snug. And now we're gonna go ahead and snug this down. Again, the instructions do have a torque rating for this. I'm just gonna do it by feel. Pretty tight. And then we're gonna take these caps off. Working with this smaller line set is much easier. It's much more flexible. This thicker line set, 3/4, whatever it is, it's a bear to work with. All right, so you're gonna line this up. There we go. Then after it can tighten a little bit, I can go ahead and use the wrench. Okay, now that I've got it fairly snug, I'm going to bring in my other wrench to kind of take the pressure off the coil. Snug it down. Carefully. There we go. Alright, let's thread this bad boy on.
So it sounds like it's not over. So I realized when I've installed these in the past is once you tighten these on, it's kind of tricky to get the insulation on behind it and tape it up nice and cleanly. So I'm gonna go ahead and put the additional insulation around the pipe and tape it up now before I connect it, just to get a better insulating seal at the end of the pipes here. Now, it's with this in place, I'm just gonna hand tighten it first. So then I'm just gonna tighten this down. One thing I like about this system is these fittings are on the outside of the condenser. The 310 unit are on the inside of the condenser, and it's a little bit more difficult to work with to get the lines in place and all that. So it's nice these are outside. Tighten it down, and I'm going to do this till it gets pretty snug. Okay, now I'm going to put some torque on it. Okay, that should be good. Now, I'm going to spray some soap water to check for leaks. I'm not going to open the condenser refrigerant yet, but there is some refrigerant in this line, so I'll go ahead and do a quick spray for checks. Okay, I'm just going to put a little soapy water around here, see if we see any bubbles. If we saw any bubbles, it might mean there's some sort of leak, and I don't see any, but we'll check for leaks again further along in the process. All right, then we are going to repeat this process for the liquid line set. I'm going to get it in line and tighten it first. Okay, come back with our wrenches. And then crank it down. And then this won't take as much force as the last one once we get it snug. Once you get it all the way down, we're going to put some torque on it. Alright, it's pretty good. I think we're going to be alright. Do a quick leak check on this one too, and then we are connected outside. So now I have connections both here and at the air condenser. Now what I can do is pop these off, open the valves, and that will connect the refrigerant from the air handler to the line set to the condenser. So I'm going to open them up here, and I'll open them at the condensers as well, and then we'll check for leaks. Here, to open these valves, Allen wrenches. This one looks like it's an 8mm, which was the one I couldn't find. I finally found this old one in a car kit. Stick it in there, and then you can hear it. Open it all the way up. Okay, then we'll do the same thing with this. This is a 5mm Allen wrench, I think. All the way up. So put the caps on loosely for now. Alright, so now we need to do the same thing at the outside air condenser. Open the valves. And we can hear the refrigerant. And now that we've got the lines open, some pressure on them, use a little bit of soapy water, look for any bubbles. I'll do this here, and I'll do it inside as well. If I don't see any bubbles, that's probably a good sign we don't have any leaks. No bubbles. Alright, no bubbles here. And then we'll also check for leaks here.
No leaks, good to go.
Now with the line sets tied in and leak checked, we're pretty solid. I really only need to connect the thermostat wires, and connect the power, put everything back together, and then we can fire this thing up. Okay, so now it's time to do the electrical, and basically we gotta pop a hole through here and then get our power from our disconnect. And then we also need to do the thermostat wire as well. And I'm gonna show you a little funky trick here with the power in. These systems are kind of strange in that you're supposed to have, well, it's recommended to use 8-gauge wire here. However, these little connectors aren't really adequate for 8-gauge wires. So I'm gonna show you what I did to kind of make it work. And then again, we're just gonna run our power wires from here to our disconnect. And then we're gonna connect our thermostat wire here. And again, we're going to start by knocking these knockouts here and our knockout in our disconnect. All right, sometimes these things are a little funky, but basically I'm going to take my big Klein's pliers here. And of course, it's not that simple. Okay, sometimes these don't break easy and I don't want to bend this, so I'm going to try another trick. I'm going to drill a hole through it. Gotta pry it with this. These things are... Alright, so this is becoming a pain in the butt. These are not popping out easy, so what I did is I used a paddle bit to get through. Alright, for this small hole, a 7/8 paddle bit will work. A hole punch or knockout thing would be better, but... Alright, so making these holes is a super big pain in the butt. Really, I think the right way to do is get like a knockout tool that can cut through sheet metal better. Now, I can feed my wires through. And then this is the nut for the other side. And I just snug the nut up on this side. Actually thread it so it's nice and snug. Alright, and then these are our power wires. I'll pull a little bit more of that slide through. Okay, now we got to get our power wires in the disconnect. I'm going to pop a hole out right here. Alright, now that we have the hole in there, we thread the other side of our wires through. To get the wires through, we can tighten this up. There we go. Good stuff. Now what I'm going to do is just thread in my thermostat wire through this flex conduit. And that's mainly just to kind of protect it a little bit and to clean up the look a little bit. And we'll put conduit clamp on. Basically, pretty simple. This on. And snug it down. Boom. Take this end off, and we can feed it through all. Okay, slide on the lock nut. See, I've got my thermostat cable and my power cable's about to link. Gonna strip this back a little bit, expose our wires. And one of the things you need to be careful is you want to keep these low voltage wires away from the high power wires. So I'm keeping them separated here. Just strip all these back. Wire up the thermostat wires. Just gonna unscrew this. Take that out temporarily. And for the C, I'm gonna use a white wire. This could differ depending on individual setups, but as long as you match the wire colors to how you set it up on the inside to the air handler and the thermostat, you should be good. So in this case, my C wire, I'm gonna use the white. So I do a little bend like that. This back like this. Alright. Snug this down. Nice and snug, and I'll repeat that for the rest of the wires. Alright, and there's the thermostat wires wired up. Okay, to wire up the main power, it's really supposed to use 8-gauge wire, which is pretty thick, and that's a little bit big for these connections. What I did in order to make it work is I got these little kind of lug extensions here, and this part of the lug will fit in there, and then this part goes over the wire like this. So I'm going to put my ground wire right here at the ground, and then these two will be the two hot legs. Doesn't matter which one, because this is a 240 appliance, and we're just going to screw them down. Alright, I'm going to put my screw back through. Tightness now that I got it in there. The same thing with our hot wires. And to get these on, just gotta screw this down nice and snug. And to install these, we just back the screw out. Again, these little lugs I think are the best way to go for this application because the 8-gauge wire is just too big to fit in here. So these lug extensions seem to be the solution. Snug them down.
these are the hot wires. Obviously there's no power on right now. This is one of the legs of 120, and this will be the other leg. When we get those hooked up, we'll have our 1 hot, 2 hot, which gives us our 240, and our ground return. Nice and snug. Double check this one. Nice and snug. And now that these are in here, I'm going to come back and snug these down a little bit more. Alright, so now we have a nice, good connection. Again, our 2 hots and our ground. And also, we're good because our hot wires, our high voltage wires, are spaced from our low voltage signal wires, so we should be good. Boom. Now I can close this up. Alright, so now we're done in here for the time being. I can go ahead and close it back up. Just put the panel back on, line it up. Alright. Once it's in place, you kind of lift it up to let the screw holes line up and put our screws in. In my case, there's 4 screws, I believe. Boom, boom, and boom. And this is nice and sealed up. Alright, now I gotta wire up the wires from the air conditioning to the disconnect. Essentially, these 2 hot wires will go up in here. I can't really see them on the camera. Go up in there, and then another one over here. Then we tighten those down, and then put our disconnect switch back in, and it is powered up. Now right now there's no power going to this, obviously. This switch in is what allows the power to make it all the way through. Turn this off, you can kill the power to the unit. Okay, so there it is, all wired up. Now I'm just gonna put this back on. Okay, and then I'm gonna leave the disconnect in the off position for now, and then we can put the lid back on. As a reminder, I have 6-gauge wire coming from the main panel going to the disconnect, and then from the disconnect to the AC condenser I have 8-gauge wire, and then the kill switch is right there. Just pull it out. Again, I'm not a specialized electrician, just showing you what I did to get it done. The system does recommend to get a licensed electrician to go ahead and power the unit up, so just a little FYI, but I'm just showing you how I got it done. So the air handler in air conditioning mode is going to create some condensation. We have to get rid of that condensation. So on the air handler itself, it has these little tabs. We can go ahead and pop this off, and then I'm going to hook up a drain, and I'm going to hook up a safety switch, and what this will do is turn off the AC system if for some reason this gets backed up and it can't drain. Alright, so this side would be the drain side. This is a 3/4 inch PVC threaded, male threaded fitting. Nice and tight in there. I'll put another one on this side for the overflow. And then that's gonna go just like that. And then our drain will come out of here. So now I have to bring all my control wires in from the thermostat, from the air condenser, and from the safety switch. And I can put them all through here to get into here. So I'm going to thread them through this grommet. That's going to go in here, and then the wires will slide through there so we can get into here. So I've got all the wires in there. I'm just going to start stripping them now. Okay, so I'm wiring up the thermostat now, and this may differ slightly depending on how you get your thermostat set up. It's a little tricky, so colors may not always match. But basically, there's letters on here, and there's letters on the condenser, and you'll kind of match some of those up, and then you'll also have letters on the thermostat. So I'll try to explain my setup here in a minute, but I want to show you just how to make the connection. In this case, these 2 blue wires, one's going to the condenser, one's going to the thermostat, and it actually needs to tie into the air handler as well. So I'm going to splice these 2 together, and then hook them into that there, and I'm just going to do that by twisting them together. Okay, so now those 2 wires are connected. I'll put a little loop in it. Okay, and then I need to take out this here, and this is the B, and so I'm using the blue wire for the B, and again this will correspond out at the condenser and likely the thermostat as well. And just screw it down. Nice and snug. So I'm all wired up. All right, so here's all my connections here. Some of these connections go to both the air condenser and the air handler. You can see those with these double wires. And some of these just go either to the condenser and or the thermostat, represented by these single wires. And so the colors may vary slightly from application to application. And I also wired up my safety switch here. This is a wire from the thermostat. The red wire's coming in. It's going into the black wire, which is going out to the sensor, and then that's actually coming back into this red wire, which is going to both the air handler and the air condenser. And the yellow wire, that's just going from the thermostat to the air condenser, not connected here. So that's how I did it. So now I got to wire the power into the air handler to the air handler itself. This was a little interesting because this is a connection here to the air handler, and these are real tiny wires. So that might be a good sign, and that means that this doesn't draw much power at all. However, I'm getting a 20 amp breaker on this. That I think is too much for these. These look like they're less than 14 gauge wires. What I did is I think the instructions say to use anywhere from an 8 amp breaker, which I've never seen, to a 15 amp breaker. So instead of the 15, I went with the 10 because these are pretty small wires. So hopefully for some reason something happened when these wires got hot that this would trip. But these are kind of a unique breaker. They're kind of hard to find. I'll leave a link in the description on where to find these. But basically it's an inline breaker, so you can put wires on one side and the other side. It doesn't have to go into an actual breaker box. And that's going to go in here. That's kind of nice because it snaps right into place here. So now I'll wire my ground wire that's coming in from my main breaker box to this green screw here. I'll put the heavy gauge wires in these screws here, and then these little wires will go down in here. All right, so this is a pretty simple thermostat, and I know it will work because I use this on another Mr. Cool universal system. However, we do got to make some changes in the programming. This is in the menu section. I believe you hold this button down for like 5 seconds and you'll get to this. This is the settings, and we're not going to do anything to this one. We're going to go to next. And then here where it says 200, we want to change this to number 2, which is the heat pump. So edit to 2, and then next. We're not going to change this one. And then next, this is 218. We're going to change the reversing valve. We're going to change this to 1. Next, and that should be it. Done. All right. All right, I've got everything wired up, the thermostat hooked up. I'm going to go ahead and test it now. Just going to put this back together. All right, time to test fire it up. First things first, turn on our main breakers. That's a condenser breaker. That's the air handler breaker. And then this is the other one. Now I gotta go flip it at the thermostat. All right, we got life here. So that's good. So our blower's running at least. Half the battle. And the condenser's running as well. So I actually installed this system several months ago, and it's been long enough now that I've had experience with the system both in heating and cooling modes. And right now I'm very pleased with the system. It's much better performing than our old system, and it's much more energy efficient. I hope watching my installation gives you an idea for your own situation if you think that this might be DIY-able. Where the complexities come in is it just depends on your unique installation location and the unique variables at each custom install. And it's things like running the line set. Do you have room to do that? Do you have to do any major modifications to the house to do that? Do you already have power in place? Having said all that, there are parts of this that are recommended to have professional installation. Typically we install air conditioning. A lot of times there's permitting involved. If you got to work with electrical, that could be another permit. You got to know what you're doing there. So if you're not comfortable with all those things, it may be better to leave it to the pros. So now the big check is to see how much power this thing draws when it's running. I'm going to turn the heat on here in a minute and see what our load is. And it looks like it's drawing just a tiny bit of current already. Let's turn it on and see what happens. It revs up slowly. Right now it's saying 3.5 amps. Let's see what it looks like outside. So we're running outside here. You can feel cold air coming out because we're running the heat, so the cold's coming out. I'm not sure the fans are running full speed, and we're only drawing like 3 or 4 amps of power, assuming my meter's right. So I redid my amp meter here a little bit. All right, so pretty impressive. This is saying I'm only using about 10 amps of power. This is on a heat mode, and I don't have a clue if the machine's running full speed or not. That's one of the good things about this system, is it kind of throttles up and down based on the environmental parameters. So I don't really know where this sits on the max power usage, but right now it is only using about 10 amps. All right, so I'm pulling another reading here at the actual breaker box where this unit's pulling power from. Again, a different reading, and it may be that the system's ramped up, or it may be that I didn't have a real good connection with my amp tool. The last connection, now it's saying I'm reading about 16.5 amps. And this is a cleaner connection with an amp meter here, and that is quite a bit less power than the old system used. The old system used about 24 amps constantly. This system is running 16.5 amps, and again, that could throttle up or down, I'm assuming. And then our blower is drawing another close to 5 amps as well. And I imagine the old blower was drawing more power than this. All right, so now the system's been running a little bit longer. It is now pulling 21 amps. I'm going to guess that the 21 is close to the max consumption, but it's not always running in that full power consumption. So still pretty efficient.
Okay, so the question that everybody wants to know, how much of a cost savings did I have by installing this system myself? Well, before ever starting this project, I had a local reputable HVAC company come out and provide a quote on replacing a comparable 5-ton system. That quote came out 4 times the price of what it cost me to do this installation. Now, I'm not counting my time in that, and there is value in time, but in my situation, it still worked out to be a considerable savings to do it this way, and I'm very happy with the results. I'm very happy with the performance of this. It's working very well in this application in both heating and cooling. Doing the installation myself saved quite a bit of money. So I hope you found this video helpful. Thanks for watching.
I call it the box. Looks kind of like a bat house. In any case, it looks all right, and it covers the line set. Should keep them out of the elements a little bit, and will also give us some weather protection up where we had to drill some holes. So good to do something like this.